we can do some of these together. Now, there are rules. There are things that you can see that decide, is it a function or not? So forget the top bit of this worksheet. It's what happens when you download it off a particular thing. What we're looking at are these. These are called mapping diagrams. All right? So I want you to write that down on your sheet. So these are, it says each diagram, but it is called a mapping diagram. And it shows how numbers relate to each other, okay, which numbers go together. Now you can have a mapping diagram for a relation, and you can have a mapping diagram for a function. All right. So this is where we're just dealing with numbers. We haven't put them into charts or anything yet. We're still going to consider charts and graphs in a bit. What we've got is numbers that go together. So if I look at number 1, all right, how would you interpret that little diagram?
I thought of something.
Go on.
I think you would label like possibly the left one as X.
Yeah.
And the right one is Y. And then like so it would be like when X is 5, then Y would be 6.
Okay.
But then how, like,
so we'd be looking at this is the domain, and this would be the range. Okay. So go on, Greg. What are you going to say? How can we?
I understand how when X is 5, Y is 6, but I don't understand how when X is Y, no, when X is 8 and 9, it's both 2.
That's like the range.
Well, say it again. Sorry.
Could it be like the range of like what those two numbers?
Oh,
that number.
when it's between 8 and 9, Y is 2. X
No, that's not what the mapping diagram. The mapping diagram shows very clearly that if X is 8, Y would be 2. But if X is 9, Y would also be 2. Okay. If X is 5, Y would be 6. Is there anything in the current domain that we have listed that would use 3?
No.
No, because there's no line. So actually, 3, we wouldn't say was in the range. But the question is really, is this a function or not? Okay. Now, what I need you to appreciate is functions can be really complicated, right? You see the shapes of graphs can go all over the place. They don't have to be nice and simple, straight lines, gentle curve. They can be any shape, but there are rules for functions. Go on.
So my theory is it's a function, but it's not a linear function.
So it definitely wouldn't be a linear function. Got that, haven't we? Because if 8 and 9 both give me 2, it can't be linear. So you're right there, aren't you? Right? Can you think of any particular function that you're aware of where more than one x value gives the same y? Yeah. Yeah. For instance.
Exponential.
Not exponential. Think about quadratic. Why would a quadratic work? What shape is a quadratic?
Where?
Shape of the graph.
Curve.
What's it look like?
Curve.
A U shape, yeah? Upside down U shape or a U shape. So a quadratic, the basic quadratic is x squared, yeah? Y equals x squared. So if I put 2 in, what do I get out?
4.
If I put negative 2 in, what do I get out?
4.
So there's 2 inputs, 2 different inputs that give me the same output. So that situation is absolutely fine, okay? The fact that 5 gives me an answer that's higher than 8 and 9, well, you're right, it just means it's not your linear going up, is it? That's fine. So in this situation, we are okay. And the question is it a function or not? And the answer is yes, this one is a function. Okay? This one is a function. Now, so that's fine because I can put inputs in and I get an output. Now, the function might be completely off the wall, one that you can write, but that's not what we're asking you here. It's just from a mapping diagram, can you see if it is a function. And it's, yes, it is a function because I've got inputs that give outputs. All right. Now there must be a situation where we go, actually, then that's not a function. That can't be a function. All right. So let's just have a quick look. What do you think for question 2? A function or not? Greg?
I think it was not a function.
Why?
Because it just seems so irrational. 2, if 2 is x, y is 7, but if x is 3, y is 2, and if it's just doesn't make sense.
But what you're looking at is you're trying to think, is it a simple function? But a graph could be, it can be all over the place, yeah.
Okay, never mind.
So that, but it's a good point to make, but that's an important one. That does not define a function or not. Just because it doesn't look like a nice pattern does not mean it's not a function. Okay? Now in this case,
It's a function. It's a function.
we think this one is a function.
I do.
I think it's not.
I don't think it is either.
It is a function.
Yeah, I'm noticing a pattern. I'm noticing a pattern.
Go on.
I think when one of them isn't used on the y, it's function. That's a pattern that I just noticed. Just off the two. It might just be a coincidence, but
Okay.
in that case, 3 would also be a function. 4 wouldn't.
So 3, well, 3 is a function.
4 is.
No, it's 4.
4 is not a function.
Okay, so
But it's not for the reason that you said.
Wait, what was your reason?
that I just noticed a pattern that when there's one that's not used on the range, then it's a function.
Because when x is 9, then it's y is either 7 or 6. It's both.
Oh, the x can't be 2 options. Oh.
Oh.
That was smart, actually.
This is the issue,
okay.
right? This number 9 going to 6 and going to 7.
Okay.
Now that is not a function.
That's a relation.
It's just a relation. Okay? So for instance, it's fine. It's a relation between two values. So for instance, I could say I am going to ask people how old they are and their shoe size. Okay? So the relation is each person has a shoe size, yeah?
Yeah.
Right? So it's definitely a relation, age, shoe size. But the problem is it can't be a function because I could have several people that are 9 years old, but they all have different shoe sizes.
Oh, okay. Yes.
So there is a relation between those two things, but it's not a function. We can't write a function for it.
Wait. Can you repeat that? Because I'm not completely understanding that.
Okay, so for instance, that one doesn't make sense. So the first one, the function, we're saying each individual input I choose, okay, gives me an output. Now, 2 different inputs can give me the same output, all right, and it's still a function. But if one input could potentially give me 2 different outputs, well, how does that work?
Just combine them.
Just becomes a relation at that point.
Yeah, so a relation is when there are... Now, this does lead you to, maybe lead you to a situation, which is a good talking point, actually, if you get something. Do you have a comment or a question?
If like the function is root x, and x can be 9, and then there will be 2.
Very good point. You've made a statement. If the function, so we've got a function which is x squared. If I put different x's in, I get the same y, right? Got that? You're okay with that? So if the function is y equals x squared, if I put different x values in, I can get the same y value out, yeah?
Yeah.
So -4 and 4 go in, they both give 16. Right? That's absolutely fine. That's a function.
Oh, okay.
Right. However, I said that if you've got the same input goes in and gives two different answers, then that's not a function. It's just a relation. But Thibaut said straight away, he was like, what if the function is the square root of x? So, what's the square root of 25? 5 and negative 5. Now, you might go, oh, but what? Actually, the square root of x is not a function.
How?
Well, it's just not a function.
It's not. Okay.
It's not a mathematical function. And that's because we can't solve it. Think of it that way. Can you solve? So, for instance, if I said to you, can you solve it with one value? If I said, I'm thinking of a number, I square root it and get the answer. No, sorry. Yeah, I square root it and get the answer 5. You could tell me what the number is, yeah?
Yes. 25.
I might confuse you, but if I'm going to have to come back to that actually.
Wait.
Reading.
Are you going to say if you square a number, you get 25?
No, but you can
Yeah.
still solve them.
Because we're getting into inverse functions, and I need to talk about that afterwards. But it's a good point. The square root of x is not actually a mathematical function. It is a relation. It does compare, but the problem is because two inputs give me. Sorry, one input can give me two possible outputs. So if I say to you then, I'm going to use 25, and you're going to apply my function, what's the answer that I come up with? So what's the square root of 25? What am I thinking?
5.
No.
Or negative 5.
Well, that's it. You have to give me two options. You can't tell me for certain what number I'm going to want. Yeah?
Okay.
So, for instance, if you're programming a computer, those of you that are into coding and things like that, if I wanted you to program all the answers to a particular function, there is a problem, which is if I have a function that's the square root of x, you wouldn't know which number I was wanting every time, because there's two possible ones, therefore it's not a function. Yeah?
But isn't for like a lot of equations, there's two answers that involve squares, so wouldn't technically every equation that involves a square, or a lot
Not
of
square, square root.
square roots, alright? Would
Yeah,
that all not be
exactly.
equation?
But not equation,
Not
functions.
be, okay.
Equations are something different.
What? Like, is a function? Like, what's like the definition?
So a function is something you do to your input. Okay? So it's a set of operations. What are the mathematical operations? Addition, multiplication, subtraction, division. So a function is a combination of those things. Okay? However, it can only be considered a function if one input, do the function, gives me one output. If one input to those set of operations gives me two or more possible outputs, it's not a function, it's just a relation.
A combination of, what are they called, the mathematical?
Operations.
I have a, can you give me like a real world example of like a relation?
So, like I said, if you were to record people's ages and their shoe size, you might have lots of people the same age, but lots of different shoe sizes. So there's no way you could write a function and put it in. It's quite nice if you think about if you're trying to program a computer or your calculator, for you that did that, you know computers and calculators are stupid, right? That they are only as clever as the person that's programmed it, right? They have no intuition, they have no imagination, they have no thought process, they follow a set of rules. So if I programmed a computer to say, if I input a shoe size, if I input an age, tell me a shoe size, what would the computer need to do?
It would need to have a function that knows what shoe size is,
Yeah.
like what age yields what shoe size.
Exactly.
But
And can you do
there's
that?
no function.
There's no function because one age could be any shoe size.
Well, you can do it with the average.
Like I really,
But there's
I got
like there's a
different.
range. Shouldn't there be? Like, well,
No, but that's different. That's when we are analysing a relation. So there is no mathematical function.
okay.
Yes.
like I think I just got this now, and what made me get it is I was looking up how to convert Fahrenheit to Celsius the other day, and I just thought of that just now, and I was like, oh, that's a function because you put in the input, which is the Fahrenheit, and then on Google, the computer comes out with the output, which is Celsius, and to get to that output, there's a function that you do with the Fahrenheit that turns it into Celsius.
Exactly.
Oh, okay.
But because a computer, I don't know whether you've ever used Excel and things like that. There's like something I used to use, which is a lookup table. It has, if I have all my data in a table on the computer, I can put in everyone's age in years and then everyone's shoe size. And then I can say to the computer, if I type in an age, give me the shoe size.
Yeah.
The trouble with that is if all the shoe sizes are different, it will only give me the first one. It's like, well, that's no good.
Yeah.
What about everyone else's? But that's because it's not a function I can't do. If I could say everyone that is 9 years old has a shoe size of blah, then the computer could do that. Like you say, Celsius to Fahrenheit, Fahrenheit to Celsius, that's a mathematical function. But there's lots of real world examples where things are not functions. But this is where we then go into what's called modelling function. We try and fit a best fit function. So things that aren't really functions. And that's when you start getting, you know, your statistical models for insurance companies and things.
Yeah.
Yeah. So anyway, let's have a look. What about the rest of them on your sheet then?
So like either.
5, yes.
Can only be 69
Yes.
Fahrenheit.
7, no. 8, yes.
Right.
That's only whatever.
So guys, 5, function or not?
Yeah, but wait.
Yes.
Great. So,
Yeah.
let me
6.
Yes.
Yeah.
Multiple.
7.
No.
No. 8.
Yes.
Yes.
Okay. If we're looking at it with
Okay.
straight,
Now.
multiple could be 1.
What are you saying? Multiple? What do you mean multiple? In the output?
Yeah, multiple
Right,
inputs
guys.
could be 1 output.
Oh, multiple inputs could be one out. Yes.
Yeah.
But
That's not
multiple.
Example.
Just to add some vocabulary for you, guys, you paying attention? You can have what's called many to one, or one to many. Do you get where that comes from? So many to one is where more than one output goes to one. So many
How can you have
to
one?
one. So many, more than one, to one. One. Okay? And then one to many,
Is
One.
too many.
to many. Okay? So one to many,
No.
not a function. Many to one,
Yes.
function. Okay? So, remember, go on.
I was just thinking because it's kind of hard. Like I know that, like I gave the example about how one input can't have two outputs, but I can't think of like any example where two output gives one input.
Oh,
Go on.
2 outputs.
Oh no, sorry, two inputs gives one output.
Yeah.
A real world
It's like a real
example.
world example that.
Yeah.
Oh.
How's that work?
You mean where it's not a function?
No, where it is.
So where it is a function in a real world
Okay, so
situation.
where there's 2, 1 here that goes to 2.
No, where two inputs has one output.
Many
Like
to
here.
one.
Okay, I'll give you one.
I have wait, can I ask?
Go on, go for it.
So, you know how we were talking about the age and the shoe size?
Yeah.
So, imagine that these are ages.
Yeah.
And these are shoe sizes. So, say when you're 5 and 6, the average, like, or the shoe size is both 5. So like both of those ages, the shoe size doesn't change.
Okay.
I don't know if it would work like with money, like currency, like how like comparing different monies.
Well, I
Like,
think-
like currency exchange.
Oh yeah.
Well, currency though is a one to one, isn't it?
Yeah.
Currency is 1 to 1. I have
Yeah.
one amount of money. I want to
Okay.
exchange to another. I get one amount. So 1 to 1 definitely function. Yeah.
Yeah.
Right. So that's where we've got the 1 to 1 situation. But what about a many to 1? Is there a situation you can think of?
No,
Like-
no, not money.
Yeah.
Not in money,
Why not money?
because that would be a bit unfair if I had several different amounts of money that all, unless I guess you talk about
Different
lots
currencies.
of different
I think
currencies.
that's
Different currencies, like
Yeah,
Oh, okay, if that's what you're saying.
yeah, like if the US
But-
and the European
But
are
the
so
thing there is though,
close,
I would be getting really complicated with my input would be different
yeah. That's kind
things, completely different things, yeah?
Yeah.
But what I'm thinking of, for those of you that do your physics or whatever, what about, let's go roughly, time of day being your input and height of the water against the wall in the marina.
Okay.
Oh.
Tide heights, they go up and
Yeah,
down and up and down. At 6 a.m. it's this height. At 10 a.m. it's a different height. At 10 p.m. it's the same height it was at 6 a.m.
Oh.
Okay, yeah, I get that.
Yeah?
That's actually a good example.
The
Date and where the moon is relative
Moon
to.
cycles.
Yeah. So things that go in a cyclic pattern like that are definitely.
So two different dates can have the same moon cycle. Yeah, okay.
So like a clock.
Oh, so you're saying when two different cycles overlap, could be many to one?
No,
like
so
the
when you've
cycle-
got something that tends to go in a cyclic pattern,
Yeah.
and you'll see one of the graphs.
Yeah.
Time of day to height of the sun. Like there can be two different times of day.
Exactly.
But they can have the same height of the sun. Okay.
Exactly, yeah.
Okay.
Distance. So you've got to think a little bit more kind of different situations. You can't go money for this one, money for that one. It doesn't work.
Oh no, that's what I meant. Like
I know,
two
but that's
sep-
why it's harder to think of one because you have to think more scientifically. Yeah.
This is a really might be a terrible example, but on the clock, the
Yeah. Universal
Like-
clock's right place.
like the distance. I don't know how to word it.
I think I know what you mean.
Oh,
No, yeah.
The distance between
Actually,
the minute
there are exam questions like that.
The
It's-
distance between the minute hand and the hour hand.
Yeah, but like yeah.
Yeah.
Yeah,
You
you
just
just say
say-
it, say it multiple times a day.
Exactly, yeah. All right. So let's just move on to the next thing, because this is all basics of functions. So, right, we've now got a different situation. So we're not, these aren't mapping diagrams, these are number sets. We've got relations or functions. And we could do it, we could set these up as mapping diagrams, or we can just write a domain and range. So this is introducing you to writing numbers, domain and range as a number set. So for instance, the domain of this is just all the
Yeah.
The X value.
these values.
I think I can get this. So
Yeah.
with this one, like you see those two right there, the farthest two. -8, 0. They both have the same one. Okay. I think that's an example.
Case
What?
rested.
Yeah, right there.
This
right.
this one.
No, in question one.
No, in question one. Like -8 and 0 can both have the same output.
So
So that is a function.
that could be a
Could be a
function.
function.
Yeah. Right. So the domain, but the domain and range of this, the domain would be
-2.
-8.
Oh, sorry. -8, -2.
-3,
-3,
-2, -1, 0. Okay? I do my squiggly brackets for the set. The range is
0.
-4,
-4.
0,
0, 3,
3.
3.
No.
Just one.
We just write 1, 3.
Yeah.
So just to show you that domain and range, they don't necessarily, if I'm just writing, like, have to show the relationship between the numbers. I'm just asking you what are the possible values.
You forgot 5.
Did I forget 5? Yes, I did forget 5. There should be a 5 there. Okay? So you'll see that there is more numbers in the domain than there are in the range. And that's fine, because you're not asking yourself. So is it possible that this one is a function?
Yeah.
Yes, it is possible, okay, with what we're given.
But how can we find like a direct fact?
Well, because then you'd start researching into how, if I plot those points on a graph, which is where we're going to later, how could I make a function fit those points? That's what maths is about, making a function fit the points I have to enable me to make predictions. So all we're doing at the moment is trying to understand what makes a function. When can I not make a function? When is it not possible?
Do
Yeah.
you have a domain and a range if it's not a function?
Yeah, we still have a domain and a range, but it's just a relation. We still have a domain and a range.
In our relation, like, what's
So-
the difference? What's the problem? Like, is it only many to one? No, it's only one to many.
So relation is when you have one to many. Yeah.
But will that seem like, oh, that's definitely a function? Or no, sorry, that's definitely a relation. Like,
Well, if you've not got the one to many, you've got a situation where you could probably fit a function. Now, not necessarily going to be a nice simple one, but you know, we're just looking at the moment. Would it be possible or not to find a function? Okay. Are there any there that we're supposed to be finding domain and range that is not going to, definitely can't be?
7.
So 7 can't be a function because?
Because there's two -8x values that yield this. Never mind. There's just the fact that there's two -8 values.
So two -8s give two different answers.
Yes.
So this one would not be a function. This one would just be a relation. But we can still state the domain and the range of the relation. Yeah?
Also, two.
Also 2.
Yes, because there's two 1 values, but two x values that are 1. No, there's a 1x value that's 1, but they give two outputs.
Yeah, so there's 2 1s with 2 different outputs. Yeah. So this one we would say is also a relation.
so when two of the same value, when like the same value differs, like it forks off.
Exactly. So if I was
100% a relation.
if I were to draw a mapping diagram, in my domain I would have a 1, and over here I would have a 0 and a 9, and my line would have to go to both.
So that makes it like a guaranteed relation.
That means it cannot be a function. It's a relation because we've been told we have coordinates that go together. Whatever situation that is, it might be age and, you know, how far you can throw a cricket ball. I don't know, but there's definitely a relation between that.
Okay,
But-
I also have sorry.
So Kieran has hand up now.
So then number 4 would be.
No, we haven't got 4. So 4 would be a relation because?
Negative 6 and
Negative 6.
Exactly. So I've got -6 with 9 and -6 with -1. -1 means it can't be. Okay?
And also 9, 5, 8.
Which one are we looking at?
For functions, 5 and 9 are also
5 and 9 are. Yeah.
sorry, I meant to tell you the relation.
Our relation. Okay. Right. So you can go back and do those probably. Let's have a quick look at. Let's look at it from graphs, because people assume if I can graph it, it's a function.
Wait, I have a question.
Yes. What's your
Can
question?
we go back? I was 8 relation.
Is 8 a relation?
Wait. 5. Sorry. I was 5.
How is 5 a relation?
It's not a relation.
No one said it was. I
I
don't think.
heard something.
No, I think.
4.
Yeah, I know.
Okay, so the graph, there is a test we can use on a graph, but let's look at it first. What would you say for the first one?
Yeah.
Is it the one on the back?
Oh no, it's the next page, guys.
Yeah, sorry, they're not in the order. So we kind of know this first one. It's a linear function, isn't it?
Yes,
Right? So this one is a function
because you put in.
because you can see, right, there is a test for a function, and the test is a vertical line test. Okay? So this is an important one for you to use, a vertical line test. And the vertical line test is, does a vertical line cross the graph only once or more than once? Okay? If the vertical line only touches it once, it's a function. If it crosses it more than once, it's not a function.
Interesting.
Because I have a one-to-one situation with this linear function. Okay? In the quadratic, potentially a quadratic, if I did a vertical line test anywhere on the graph, okay, I can see anywhere I'm going to have a one input gives one output. Now I can find that that same output is going by a different input, so I have a many to one, but I'm fine because my vertical line test passes. Yes?
I know why the vertical line test is like a test that checks if it's a function or not.
Yeah?
Because if you think about an example of one too many would be a vertical line, because it doesn't matter what one x value can give multiple different y values, and that would make a straight line. And if you put a straight line on a straight line, it will touch more than once because it's two straight lines on top of each other.
Wait, can you like?
Yes.
visual that?
Say it again.
I completely follow. Yeah, I know.
So what I've done, and if I draw anywhere on the line, anywhere on my axis, a vertical line, all right?
Oh, okay.
Vertical line, does it cross the graph more than once? So these two, no, I can put a vertical line anywhere, it only touches once. Okay? Number 3, if I put a vertical line anywhere, it will only touch once. So this is what we were talking about, a cyclic function. Recognise it at all?
Yes, which one?
What are they called, basically? You have a...
It's an exponential.
It's not an exponential function.
It's a quadratic.
It's not a quadratic.
Linear either.
It's not linear.
That's exponential.
It's not exponential.
It's because it's changing. It's the same thing, but it's negative and positive each time.
It's a cyclic function.
Cyclic function.
And we get those when we do a trigonometric function. Sine or cosine. Have you not done those graphs yet?
No.
That's what they look like. So we talk about that. Okay? This one is not a function because if I draw a vertical line, I get 2 possible answers. So my one input of 2 gives 2 possible answers. So this one is not a function. The vertical line test has been failed. Okay? Would anyone know what that graph would be?
This is a relation.
That's an
It can touch more than once.
That's a...
Exponential.
It's not an... You've got exponential in the head. Exponentials are functions. Exponentials... actually, we haven't got one on here. An exponential function looks like this. Okay? A to the power of x, it increases exponentially, exactly. It gets bigger and bigger and bigger. So an exponential function is fine. This is an example of a square root function or a root function. So if I take the square root, that's what I would get. Yeah? All right? Or, right?
So if x was a square root, this is what your line.
So if you were to draw the graph, the proper complete graph of a square root relation, you would have to draw a graph that looked like that.
I'm confused. So how that would be a square graph in the way like how would that equation look? X
It would be like f of.
So if I were to plot y equals the square root of x, and in this case then take away 1 to drop it down, okay? The square root of 4 would be
2.
2 and
But that's
minus 2, but then a minus 1 to drop. So I've got 2 possible answers, yeah?
Wait, but it's 1 and negative 3 in the graph.
I know, I've minus 1, yeah? Now, I'm just saying it's roughly, yeah, that kind of. Right, let's just check then. So this is a,
Number 5.
That would be a relation because it's touching.
good, it's not a function, okay? Because although at this point it passes the test, and at this point it passes the test, at this point it doesn't. How many possible solutions for that one input?
2. No, multiple. 1, 2,
How many?
3.
1, 2, 3. Yes. There are 3 possible outputs for that input. This one here, and this one here. Yeah? What about this one?
That is a function.
Is a function. Anyone recognize it?
Yes. Oh. Parabola. No.
Quite interested in what you're stating as quadratics. We need to talk about these actually. This would be an example of a cubic function.
Oh.
Okay, cubics look like this. If you have a cubic with a quadratic part to it, it ends up looking like that. Okay, does that make sense then? How a function graph? So just because you can draw a graph doesn't make it a function. Because if I were to put that into a graphing calculator, y is root x, it wouldn't give me any of this. It would only give me that bit. All right?
Oh, because it wouldn't give you like the other option.
It doesn't give me the negative
You have to complete
options.
that yourself.
Does that make sense to you?
But
Okay.
isn't it always going to be symmetrical?
Yeah, but your calculator is too stupid to know that. Right? So another relation, right? I don't know whether we've got those. Another one for you to consider, right? If we had graphical calculators, this would be more interesting. This one, x squared plus y squared equals 25, for instance. Function or not?
That is
That is a not a function.
I don't think it's fun.
If you do it on your calculator, the shape of the graph you get would look like this.
Yeah, that's not.
Minus 5, 5, 5.
No, but it's not because the calculator only calculates the positive side, so it would be a
Yeah.
full circle
Yes.
in real life. And then it wouldn't be a function.
Your calculator would only... That is the equation of a circle. X squared plus y squared equals the radius squared. Right? But if you put it into a computer or a calculator, it will only give you the top half. Okay? So that is why we wouldn't. Anyway, back to these sheets. Really then, that's kind of what we need to talk about, domain and range. You've got some others to have a look at, right? You'll also notice there is a second set sheet which kind of repeats all that stuff for you to have a look at to give yourself a bit more practice on it. Okay? So it's a bit different, this one. It says, what's the domain and the range? How do we do domain and range from a graph? What do you notice about the dots on the graph, by
First
the
of all,
way?
it's very important. It's the same as a line graph. Well, what do you call it?
Linear function.
A line. Wasn't those lines? A legend
Inequalities thing.
line. Oh, that's music.
Do you notice how that dot is filled?
It's filled, which means it's
This dot is empty,
Empty.
so it's not equal to. So my domain in this case is x has got to be less than 0. Think about that's where the 0 is. It goes from there through to that point, and what's that value?
5.
Greater than or equal to, because it's a filled dot,
5.
negative 5. Got that?
Yes.
And the range goes from So it's y must be less than, what is that, 2, 3, 4, but greater than and equal to -1.
Huh? Oh yeah. Okay. Yes.
Yeah?
Yeah.
Could you
I don't
have
get
one more
that.
example?
Okay, so this one, I notice here are my 2 dots. They're filled. So I know x goes from this point to this point on the x-axis. So I know x is between and equal to 4 and -4, yeah? Got that? Between those 2 points on the x. On the y-axis, I go to that point and then go down to that point. So y must be less than or equal to, because it is on that point, -1. Greater than or equal to, because the dots are filled, -5.
So when they're not filled, it means it's
Not equal to, just like your inequalities. So just to show you, the x values are what x values have been put in to give me what y values. Yeah? Okay. We can always talk a bit more about this tomorrow if you